Usually when the students start with the experimentation, they tend to rush to it. They take the initial preparation for granted. However, it is the initial planning and the organization that makes subsequent experimentations successful and useful. In this module, we shall understand, is there a formal need to appreciate the organization? And if we agree to that, how to organize and perform the experiments. A paper titled Mene Simulation Studies, The Incredibles, was written by Stuart Kirko et al. In 2005. This paper gave a yardstick, certain requirements that must be met in order for experiments to be credible and reusable. They argue that whatever experiments are to be done must be repeatable so that the fellow colleagues can use the seed values, the parameters, and the values of those parameters to start with the experiment, repeat it, and perhaps extend it. The experimentations should be unbiased. It means that the results should not be confined to a certain scenario. They may be applicable in one scenario, but they may be highly unapplicable in another scenario. This makes the usability of the experimental results very little. The experimentations done have to be rigorous enough so that whatever experimental results are obtained can depict a true real-world phenomenon. And finally, whatever results we obtain through the experimentation should not violate the fundamentals of mathematics. Here is the summary of Stuart Kirko's work that shows that between 2000 to 2005, 151 papers were presented at Moby Hawk. 75% of them claimed to be simulation-based, but 29.8% of them did not state the simulator which they were using. 87.5% did not even mention the confidence intervals in their systems. 93% did not even bother to declare the initialization values and the biases. This means that the work done between 2000 to 2005 for Mene tended to be unreliable and literally futile. If we don't want to do like that, we have to agree to make our study very well organized. This block diagram and the relationships between different blocks shows an organized way to perform the experimentation. We shall go through each of these one by one. The first important concept that we need to address is the model that we are using for experimentation. The model comprises the executable, which builds using the C++ files, external libraries, and the NED file. The model actually remains invariant during the course of experimentation. It is important to note that the initialization file is not part of the model. The next important concept is the study that we wish to undertake. Usually speaking, a study comprises one or more experiments. It even can use one or more models. This is the real-world job, that is, we perform the experiments. The experiment is nothing but exploring the effect or the behavior of a certain parameter. An experiment is closely tied up in a one-to-one relationship with a model. That means a model is used in an experiment, and an experiment uses a model. Another important concept that is closely related to to model and the experiment is the measurement. Measurement is actually a set of simulation runs which are done on the same model with the same set of parameters. Generally speaking, we characterize measurements by the initialization files. These initialization files pass different seed parameters to perform the measurements. The measurements may involve repetition just to determine or average out the real close value. The replication itself is characterized by the seed value it uses. And finally, the run. Run is actually the instance of the simulation process which is performed. It is related and characterized by the PC on which it is running, the time of the day, and the date. Coming back to the block diagram once again, here we take an example of doing a study for handoff optimization for mobile IP version 6. If that study needs to be done, it has to be based on a model. So the model that handoff study needs to be done has to comprise of mobile IPv6 nodes. Mobile IPv6 nodes would be based on compound modules. So a study can use one or more models. Here, more models can be considered for IP version 6 with mobility support, IP version 6 with zero mobility support. Here, it is important that when we do the study of this model is to be done using the experiments. These experiments are the real thing that network modeling and simulation has to address. Here, for the experimentation, say we want to determine the effect of the number of hosts within a constrained spatial environment, the traffic load that is injected into the network on each ad hoc node. While performing the experiment, we would be taking one or more measurements. Here in this case, when we assign values to the parameters such as the number of hosts is equal to 10 and load, for example, is 3.5 erlings, we can take measurements. We can also take measurements with number of hosts is equal to 2 and the load is equal to 1.